So again, we'll continue using a deductive reasoning for this example. So it says, have you ever been emailed a number trick? They're fun, always have a general pattern to them, and can be solved by deductive reasoning. So consider the following number trick, and we have this explanation of a number trick here, and it says, choose any number, add 5 to this number, double this result, now subtract 10, add this result to the number you first chose. So I'm going to test this. I'm just going to pick a number and run through this and see what the results are. So how about if we start with something like, how about 9? Choose a number, 9, add 5 to this number. 9 plus 5, that's 14. Double this result. That'll give us 2 times 14. It's 28. Now subtract 10. 28 minus 10, that's 18. Then add this result to the number you first chose. So 18, add that to the 9 that we first chose. And that gives us 27. So it really doesn't tell us anything other than what our starting value is and then our result. So I'm going to maybe try it again. And you could pick any number, but since I'm trying to see something that starts to generate, I'm going to keep it simple. There's no need to get elaborate or exotic with it. So I'll just keep it simple so that we can recognize something. So I'm going to try maybe 5. Choose a number 5, add 5 to this amount. 5 plus 5, that gives us 10. Double this result. 2 times 10, that's 20. Now subtract 10. 20 minus 10, that gives us 10. Add this result to the number you first chose. 10 plus 5, that gives us 15. So I'm still having a little bit of difficulty seeing what's going on. So maybe I'll try another one. And again, I'm going to keep it simple. So here's maybe 2. Add 5 to this number. 2 plus 5, that's 7. Double this result. 2 times 7, that's 14. Now subtract 10. 14 minus 10, that is 4. Then add this result to the number you first chose. 4 plus 2, that equals 6. So as I see what's going on, I started with 9 and I ended with 27. Started with 5 and I ended with 15. Started with 2 and I ended with 6. So it seems to me that whatever number we start with, when we end, our result is going to be 3 times that number, right? 9 times 3, 27. 5 times 3, 15. 2 times 3 is 6. So what we're going to do is we're going to see if that's the case. We're going to come up with a general pattern. So whenever you come across a number trick, you should always go ahead and test it out, run it through. See if you could see something developing, and then do a general pattern to help confirm your results. So for a general pattern, it says to choose any number. So the number could be very large, 2,357, or it could be a negative number, but it can be any number. So one way to represent any number is to use a variable. So we can use any variable. How about if we use the variable n for number? So if we choose any number, n, add 5 to this number, so that would have to be n plus 5. Double this result. So I'm going to do 2 times n plus 5. And if we distribute 2 times n, that's 2n. 2 times 5, that's 10. Now subtract 10. So if I subtract 10, I'm left with 2n. Then add this result to the number you first chose. So here's the number I first chose. So I got 2n plus n. That's equal to 3n. So I thought 9 times 3 is 27, 5 times 3 is 15, 2 times 3 is 6, and of course 3n. So take whatever number you have, multiply it by 3, and that's what we're going to end up with. So this is known as the general statement. So for this number trick, whenever you choose a number, your result will always be 3 times that number. So when you come across these number problems, always run through a few samples. Sometimes you'll have more than one variable. It may say choose a number, do this, do that, then add another number. So you may be using 2 variables. But pretty much, rather than use a specific number, we just use a variable and carry out the arithmetic. And the good thing about these number problems is they allow us to see what's going on algebraically. It helps us to determine what's going on using mathematical skills. It helps build our math prowess.